All right, it is demo time again. I don't remember if I posted a video yet about the Vecto communication library I wrote starting in December. It's based on lightweight publishing over multicast UDP for periodic telemetry and does TCP for commanding, um, both for to have a centralized server that can do the dispatching, but also logging and permissions, things like that, as well as an HTTP server for uh, bigger transactions, less frequent transactions, like configuration and logs. So I've been building an application framework around that. I don't know if this would be called a framework. I think it probably most people would not call it a framework because it does not have tooling, but it is built on top of Actor framework, which does have tooling. So yeah, but it is meant to provide all of the common functionality for doing things like group based data publishing and logging and organizing applications in a cleaner and more consistent way than Actor Framework alone. So for the little demo I have now, so there's quite a bit to this library already. It's called Volatus, which is Latin for flight. But we're gonna go ahead and run this demo, and I'm gonna scroll back up because I had this running already. So it's already got event logging baked into it. Here's a really basic view, but I can pop open these little sim windows and they definitely don't look like they're doing anything on their own. But now I can pop up a chart, and the neat thing is I can keep opening charts. And now this chart is responding to the group data coming from this window. They're all uniquely identified dynamically when they get created. Do another one, and we can see this is trying to find the data for a third sim window, which doesn't exist yet. So we'll create that. That lookup then succeeds, so it stops complaining in the event logging. And I currently have these just updating at about every 500 milliseconds. But we can go ahead and look at some of these errors, maybe kind of in these small windows. So yeah, so this was saying that group sim3 doesn't exist, which is what it was looking for. So this is all fine and dandy. This is a single application. Each one of these windows is a separate actor. However, I have a layer above actors called task, which gives a little bit more granularity on initialization uh, order. Doesn't require call parent method anywhere, and that intermediate task layer provides a lot of the state tracking and management, and a lot of the common application APIs, such as the event logging and creating data groups and publishing data groups. Now, the other thing I have is part of this communication library, since it does use relatively generic messaging, is I can have some debug tooling that is completely separate from um, Volatus itself or the demo application. All of the telemetry publishing is and protocols and all that is established by Vecto itself. So the only thing I need to know is the system name, cluster name. I'm gonna kind of pass over what those are right now. But basically, what I really need to know is the multicast endpoint where running applications advertise themselves. And with that, I'm going to hit start, and we can see we get all of this information dynamically from the application. So as I take Sim 1 and I move its values, we can see them updating in the list there. Same thing for Sim2. Now, I don't have this tooling very fancy yet. It's pretty rudimentary at the moment. For instance, if I create a fourth group, it is not going to show up in this list. This right now, this app doesn't respond to new groups showing up. It only responds to new applications showing up, which are known as nodes in this context. And when it sees a new node, it queries it for what groups it's publishing at that moment. So over time, this tooling will get better. But one of the things we could see that's part of the advertising data is what port is a server running on, if it is. So I can open up, I'm going to do this off screen first. I can open up, it's auto completing. So we'll go ahead and drag that over there. And we could see what the group publishing config is. And now, since I made this request after I opened Sim4, we can see that Sim4 is in there. But this is the JSON data that this generic debugging tooling is using to know what groups there are and more. Well, it knows that the groups are coming in because it can subscribe and see group data coming in. But what it doesn't know is what the individual element names are. So this, once you know of a node by its discovery, this tooling then hits up this endpoint, which it knows the port. Obviously, it knows the IP address from the discovery information. And then it can get this JSON, set up these groups that it's interested in on its side, and then register to start subscribing to data coming from that multicast endpoint. And since I don't have a fourth chart yet, here's the data from the fourth chart. So yeah, this is getting pretty decent. If we take a look at the code that's part of this demo, go ahead and close that. It closes cleanly. Hooray. But part of the Volatus stack is application and task. Application is meant to be the top level thing that knows how to get configurations and supply some of the implementation details that are extensible in Volatus and Vecto. And then Volatus kind of is the glue layer that gets all of that initialized and running once the app provides the information that it needs. Sorry for all the coughing. I've got this weird allergy thing again. Yeah, and then there's tasks. So tasks do inherit from actor in actor framework. However, if we look at implementation of a task, such as one of those sim tasks, this does not have any actor framework overrides. So I'm following stratification here pretty heavily. With this intermediate layer, I am hiding actor framework from the leaf children as much as possible. Obviously, they still get commanded and messaged via actor framework messages, so there still is that aspect that's never going to go away. But what this avoids is situations where, like pre-launch init, if you've got multiple layers, they've got a call parent method, and do you do the call parent method before your logic, after your logic, in the middle of your children's logic? So this is very opinionated about how that happens, and it will call these task level defined dynamic dispatch VIs in the appropriate places, in the appropriate order relative to everything else that the Volatus framework is taking care of. And we can see the Volatus is doing things like keeping track of state. So just before it tries to see if the task has an API that it's going to provide, and then initializes the task. I should probably change the order of these two. But we could see this show up in that event log and understand what state things are getting into. Similarly for actor core, where most of the work happens, is doing. Sorry, this is doing things like giving the task its last chance to initialize after pre-launching it, but before any of its main logic. So things that you normally can't do in pre-launching it is things like launching actors, launching other actors, or in this case, launching nested tasks. Tasks can be nested arbitrarily and still all follow this pattern. And when things like um, state and error handling will get passed up the tree inherently based if you use the methods that are available on the task intermediate layer. But this has all of the common error handling and reporting around that. So a lot of the basic state management for processes, actors, tasks that are running in an application is handled for you. You only have to worry more about your your actor's specific interests and what it is meant to do. So all of the things that you in a lot of other application frameworks that I've worked in, there's been situations where you need to remember to call a VI to report that you're running. So other parts of the application will do message registration or start sending it commands or whatever might happen. And there's nothing in the development environment that enforces that you need to call that VI. And sometimes you can lose hours trying to figure out why some things aren't working because you forgot to call one VI. So this heavily relies on using dynamic dispatch to and must overrides to enforce and steer future developers or me in 6 months when I forget what the hell I was doing, what I need to do to implement a new task. Um, Things like the task loop is optional. This might be, well, in the case of these, this is the GUIs. So if you have a task that is based entirely around actor messages and doesn't need a helper loop running in parallel, you wouldn't need to override this task loop. But it is there for situations where you want a GUI or you need some parallel operation happening, like maybe reading from DACMX or running some kind of automation loop that's generating commands to the rest of the application. Um, yeah, so there isn't much in this. Let's look at the sim task quickly. So the first thing that's going to happen is init gets called, then start gets called, then it's going to be in loop, and loop stays running until task stop gets called. So we'll look at that quick. This is just triggering an event so that loop knows to stop. And then after all that happens, uninit gets called. Now I'm not being the clean developer that I always say good developers clean up the messes they make. I'm not releasing any of the event or queue or anything else that's being used. I'm not cleaning up any of those references right now. I'm being very naughty. But that's where that would go. So the task init, all it does is gets the task's ID, uses that to create a corresponding group. The way these are done is that top level app keeps track of the count of the number of actors that have been launched and gives them a number. So you get sim 1, sim 2, sim 3, sim 4, however many times you click that button. Now group names need to be unique, as well as individual value channel names. So we're generating unique channel names by taking the group name and prepending that to the channel name. So you get sim1.a and sim2.a and sim3.a. So they're all unique. This will check and will return an error if there are any duplicates, as well as establishing. Right now, this is hard coded. Usually, in a non demo application, this would come from some configuration, and it generates that or creates that user event to be able to tell the loop to stop running. Start isn't doing anything. Um, all the rest of the magic happens in the loop. So basically, 90% of what it's doing is it's using that group that was created in initialize. It's taking all of the current values about 100 times a second. and updating them in the group and then publishing that group. So if it has been registered for publishing, this would publish. And then if any of that generates an error, we report that to the event handling. So pretty simple. On the chart side, very similar setup. Init, this one is just creating that close event. And in the loop, every time this times out, so this is running much slower. In fact, I'll probably speed this up for the future. Now this is kind of doing it the inefficient way. It is every time it wants to get group data, it is doing a lookup for that group, which has to send a message to the one of the core actors that is maintaining the groups. That's actually not an actor; it's part of the Vecto, and Vecto isn't actor framework based. But this ends up sending a request to the component that is responsible for tracking all of the created groups to do the lookup. And there's two types. There is a double numeric group as well as a string group. That is not how you spell that. So if I wanted string data, I could pass that in for the type instead. But if that lookup succeeds, I can get the data from it. If it doesn't succeed, these were the errors that were showing up if I had created a chart before I created the corresponding sim data actor. So that just gets pushed into event handling. Couple of layers, but um, nice and simple up at the layer where I would be implementing application specific code. And then similarly, the stop just generates that event to get this loop to shut down. So all in all, pretty lightweight um, bit of code here above the framework level. Application also has a very similar setup. Application does not end up inheriting from actor at all. The only thing this is going to inherit from is that app core class. And there is a core actor that drives calling these lifecycle VIs, but this gives you the opportunity for doing things at the very, very top level, whether you're using it just for splash screens and updating splash screen status until it's running, and then you close it once it fully finishes initialization, or for simpler applications like this one, where you want a bit of a GUI as your top level entry point to launch other things that happen, this could be the place to do that. So the initialization, wow, this pattern looks pretty familiar. Since the application hierarchy is not one of the tasks which share a lot of the core infrastructure, a lot of all of the APIs that are needed to be able to access the rest of the framework are provided. So with Volatus API here, you would be able to get any other API that isn't part of this cluster but has been registered. These are all kind of just the core APIs, as the label might hint at, that are going to be very commonly used. So avoiding, for event reporting and interacting with telemetry data, don't want to have to be doing lookups to get those other APIs to do things with. So they're just provided directly. But they are passed into every application override. I did create all of the overrides, even though they're not all needed. But this still looks very much like the rest of the task hierarchy to keep that very similar design patterns in places. And this is still a pretty simple top level loop or GUI for the application, this concrete demo app. And basically all it's doing is keeping track of how many charts and how many sims have been launched. And if you do that, we can create an instance. So this was that create VI that just stores that number and then uses the Volatus API to get a new top level task launched. Since this is a top level GUI, I have the simple error handler here. An even better choice would be to throw this in the event log, which I could do like this. So there's report event and report error. Report error only sends an event if it was an error. Um, and so now, if there was an error launching this task, it would get logged here. So pretty simple and straightforward to get quite a bit of data flying around an application and outside of the application.